Go, and now we've imported our image into Geogebra. Now we're going to practice fitting a model. So I'm going to plot a set of points to begin with. So to plot a set of points, just by looking at the model, you can kind of like do it like this. Make a point. So I'm going to plot points wherever his shorts are, because that's the trajectory I've chosen to go with, and, because it's kind of always around the center. I could have plotted, just as long as I'm kind of consistent is probably the main thing. Like, do I always do it from his feet, from his head, from his shorts? As long as I'm consistent. Now, what kind of model do you think this is? You might think it's a linear model. You might also think it's a quadratic model. If I was to do a quadratic model and I was to do it manually, you could potentially use the vertex. The vertex would be around here, wouldn't it? So what would be the coordinates of the vertex? And we can use the vertex form. If you can't see this input window, just go to here, go to view, and just make sure that input bar is selected. But I can see my input bar. So what I can do is I can try to fit a model. You can use this keyboard down here to do it. That's also okay. But if you don't want to use the keyboard, see the keyboard's down here. You can just get rid of it and type it in yourself instead. So let's see, I'll go, let's see, g of x or h of x equals, and then it would be, so if we're using the vertex form, it's x, it's moved to the right, so x minus, what's the horizontal shift? It would have shifted roughly, if A is the vertex, around about, it would have shifted about 14 units. Let's just start with 14 units to the right. Oops, it's gone. Let's go, I'll just call it g of x again, so just showing you can call it whatever you want. So brackets, I think that took too long to type it in, x minus 14, and then squared. So you can use the little keyboard to make squared. When you open the keyboard, you'll see there's a square option, or you can do little upward arrow 2, little upward arrow 2, then arrow to the side of that. Notice it's a negative at the front, so we should make it negative because it's an upside down quadratic. Oops, and by the way, that thing's still there. Get rid of that. If you've got little annoying points in the way, just get rid of them. See, that little thing's still there, so that's a bit annoying. Okay, that's gone now. But notice that the graph's down here, so it should have been up here. So instead we should have the vertical shift, so it's horizontal shift of 14 units to the right, and it's a vertical shift of, let's see, around about 33. So let's try putting plus 33, just doing it roundabout. Pretty close to the vertex, maybe just a little bit off, but we also need to include a bit of stretch in there as well. So maybe we need to stretch it out a bit. You could do it via horizontal stretch if you want, or you can do it via vertical stretch. So horizontal stretch by putting it in here. Remember, the scale factor is 1/. And then vertical stretch, we would just put it here. So it needs, at the moment it's a bit narrow if I've got -1. So to make it wider, notice I've got negative to make it upside down, to open downwards. So to make it wider, I need to put in a value of a that's between 0 and 1. So let's start with 0.5, see what happens. 0.5, nothing much has happened. What about something like 0.3? What would happen then? Well, it's a bit wider now, that's good. 0.3, what about 0.2? It's getting closer. See, it's getting closer to the points. 0.1, it's too wide now, so maybe in between, 0.15. This thing I'm adjusting, kind of like what I call the dilation factor. Some people call it like a scale factor, horizontal, a vertical stretch scale factor. 0.14. No, that's getting wider. We don't want it to be wider. 0.13. 0.6 is where I was meant to go. That's pretty good to me. You can get even more accurate if you want. Notice my vertex is a little bit off, but that's okay for now. So that's my little g of x. So that's how you can manually fit a model. So that's the one I came up with myself, just by using the vertex form of a quadratic and adjusting kind of the scale factor. To be even more specific, you could potentially even use some points and actually calculate yourself what the scale factor should be by plugging in some x and y coordinates. I could also maybe look into the r-squared value. I'm not sure if it's going to let me though. R-squared value. The list of points that I've made. So the list of points are A, B, C, D, E, F, G, H, I, J, K, L. So to enter in the list of points, I've got to make a curly bracket and use capital letters A, comma, B, C, D, A, B, C, D, E, F, G, H, I, J, K, L. And I've closed my brackets. The function, which function is it talking about? The function it's talking about is g of x. Oops, I'm using the wrong notation. Lowercase. Oops, something just went wrong there. Okay, so that's a bit weird. It's saying that my r-squared value is really close, but no, it's possible. But I don't think my model was that perfect. Anyway, so if you wanted the thing to do it for you, so imagine, let's get rid of my one. Oops. See how it did that? This is good to do because you can sort of see how to fix things up. So I should be on an arrow so I don't keep plotting points. I was on point, so that's why I kept plotting points, go into arrow. If I want to get rid of this thing, I can just select it, delete it off. Imagine I want the computer to do it for me. I want Geogebra, to work it out for me. So we can type in fit. Notice different types of models pop up. We've got fit sine for a trig, fit power, fit polynomial, if you want a quadratic, a cubic, a quartic, a quintic, and so on, higher degrees, logistic, log, line x, implicit growth, exponential, and so on. So I'm looking at a quadratic, that's my idea for now. So polynomial, what I've got to tell is I've got to tell it what degree. So what degree it's a quadratic, so the highest power of x is a 2. So for a quadratic, whereas for a cubic it would be a 3 and so on. Also, so make sure you just keep that comma there. So I put in degree is 2. It's a bit fiddly doing this, so just be very careful about the way you do it. Curly brackets, what points? So points A, B, C, D, E, F, G, H, I, J, K, L. Make sure you use capital letters. I'm not bothering to not putting any spaces. A, comma, B, C, D, and so on. G, H, I, J, K, L. Just arrow across to make sure everything's good. Curly brackets are in the wrong spot. So the curly brackets shouldn't be on there. There you go. So that's saying that plot. So you can see the curly point. The curly brackets contain the points, and then comma for the degree of the polynomial. Enter. So see, it fitted one for us. So now it's done a quadratic regression, which is brilliant. So it worked out a little quadratic regression for us. It's called it f of x, and that's our little f of x. Let's see if the r-squared value is going to come up. Let's see, r-squared, I'm starting to type it in. List of points again. So the list of points are here. Before the comma, I need my capital letters, curly brackets, A, B, C, D, E, F, G, H, I, J, K, L. And the function, just arrowing it back, so now I've got to type in what the function is f of x. I think sometimes they're fine with you just, and I should use lowercase, f of x. I think they're actually fine with you just calling it f. And it's saying again 1. So when my little model that I created before that I deleted off, when you expand it, it probably gets pretty close to here. So I kind of doubt that this is 1, so you might just want to double check that yourself by using another method to see if this is actually the r-squared value. Because normally when I've done this, I've got an r-squared value is kind of close to 1, but not exactly 1. Though it is a pretty good fit, but you can see it's not perfect because see the A is a little bit above the fit. And so the fit I did was quite similar to the one that they came up with. So showing you different ways that you can do some modelling. And if you want to do a linear one instead, you just select line instead. Or if you want to do a cubic instead, you just select polynomial, but you make it degree 3, and so on. Or a logarithmic, you select log. And that's it.